So we've covered a lot already about classes and methods, but in this series of lectures, we're going to dive a little bit more into the detail about classes and methods, including different class relationships, the this keyword, static, overloading constructors. We've talked already about overloading methods, but we'll talk a little bit more about overloading constructors, and then this idea of aliases and pass by value. So let's just start with a review of class design. Again, we've talked about this already, but let's do a review because it has been a little while since the last series of lectures on this topic. So a class is a concept of an object. It's like a blueprint. A class defines what objects are going to look like. And then once you have that class defined, you can create or instantiate as many objects of that class as needed. So you specify a class based on its characteristics, so what describes objects, and we represent that with instance data, specifically private instance data variables. And then you also describe objects by what they can do, actions they can take, and those actions are represented by methods. So we've got our characteristics described by the instance data, and we've got our activities or actions or functions described by the methods. So as a baseline, all of our classes contain these private instance data variables. They contain constructors. The job of the constructor is to set up an object. Typically, constructors do that by taking in instance data variables, taking in values for the instance data variables as parameters, and then initializing those instance data variables using the parameters. Now, because the instance data variables are private, we need to allow a way for other classes to access that information. So we provide public getters and setters. Public getters allow other classes to retrieve that information, so to find out the details about an object. And public setters allow outside classes to update or modify the information about an object, those variables. Oftentimes, setters will have conditional checks inside of them to make sure that the parameters contain valid values, so that allows us to restrict the values that can be given to our instance data variables. Then we have a toString method. The toString method returns a text representation of the object. You get to decide what's contained in that method, but it should be a kind of a text-based description of the object. So these are our baselines that are contained in any method that we write, any class that we write. And then in addition, there'll be a set of private and public methods. And these will be methods that are specific to that class. So this set of things here is general for all classes. We include these things. And then the private and public methods, we customize based on what class it is that we're writing. So as a review of this, let's take a look at the audio item class, which we'd previously worked on. An audio item is something that's going to be kind of sold in an audio store. Think about MP3, so a piece of music, or a digital audio book that you could download, something like that. So we said that audio items are described by three characteristics: a title, which is stored as a string, a price stored as a double, and a length, which I'm storing as the number of seconds. So here's our constructor. Again, the constructor takes in three parameters. These contain the values that we'll use to initialize our three instance data variables. So remember that parameters, formal parameters, only live as long as our method lives. So once this constructor is over, these three parameters are going to be garbage collected. They're going to be forgotten. So the only way to save this information that describes our object is to associate it with the instance data variables. So to take the value sent in as a parameter and store it in the instance data variable, because the instance data variable will live as long as the object lives. Okay, so it's important to take in the information. This is like the input that we want to use to describe our object. But in order to save that input, we have to assign it to the instance data variables. Next, we have our getters and setters. The getters are usually pretty straightforward. They just return a piece of information. Setters update the value of an instance data variable. For our set title and set price method, we don't have any checks in here right now. You can think about, for the set price, you might want to include a check. You might want to make sure that the price being sent in is a positive value, although perhaps there'd be some promotion where they'd be paying you to try new music or something. I don't know. Potentially it could be a negative value. And then we do have a check in here for set num second. So here we want to make sure that the length is at least 0 or longer. So we make sure that that parameter sent in is a valid value, and only if it's a valid value do we update the instance data variable. In this case, if it's not a valid value, we just do nothing because there is no else clause. Other things you might see in an else clause could be a system.out.println line printing an error message or something like that. And then we have our text representation of the object. Here we just create a string that lists the title, the price, and the duration, and we return the value of that string. So this is the blueprint of our class. Again, writing this blueprint doesn't create any objects or anything like that. It just lays out what an object will look like. So it just provides the definition of what objects are going to look like. So then we created a driver program to actually test this out and create some objects. So here we declare an item of type audio item, and then we initialize or instantiate that item. So these are the actual parameters that we send into our constructor. So we send in the title, the price, and the number of seconds. So these will come in as the title, the price, and the num seconds. These will be the inputs that are then assigned to the instance data variables. Then we can go ahead and, then we create a second item here, a book, sending in a title, a price, and a duration. And then we can invoke any of those methods on these items. So we can change the price of song 1, we can invoke the toString method, we can also just include our object in a print line. And remember that Java gives us a special shortcut if you include objects in a print line. It's like invoking the toString method behind the scenes. So this is the equivalent of printing out the invocation of the toString method, but because that's such a common thing to do, Java gives us this shortcut where we can just put the object directly in the print line statement. So this is what we previously covered, this idea of writing classes and then instantiating objects and invoking methods on those objects. So we're going to go a little bit deeper now. We're going to talk a little bit more about class design. So sometimes it can be challenging to decide whether or not something should be a class. Now, sometimes for our purposes in an assignment, you're kind of told what should be a class and what shouldn't. But oftentimes in the real world, it's up to you to decide what you should represent as a class and what shouldn't be represented as a class. So you don't want your classes to become too complex. And if a class does start to become too complex, it's often helpful to kind of break it down, or what's called decompose it, into smaller classes that each represent their own objects, and then to kind of spread out the responsibilities among those classes. You want to find a balance between having classes that are really super basic so that they don't depend on other classes, and so complex that they have many or complex dependencies. Okay, so you want to kind of find this balance between classes that are too simple and classes that are too complex. There's 3 general class relationships that we can talk about in Java: dependency, aggregation, and inheritance. So dependency essentially describes a situation where one class uses another. So class A uses class B. Aggregation or composition describes a has-a relationship. So this is used to represent when one class is made up of items of another class. So A has a object or array of objects of type B. And then inheritance is used for is-a relationship. So we're going to talk about inheritance later because inheritance is a very big topic in Java. So it's going to be a topic in and of itself. So we're going to not talk too much about this one now. And we're just going to focus on these dependencies and aggregations. So dependency again describes uses. This kind of relationship happens whenever one class uses another. So this happens all the time. It's happened in lots of the code we've written already. Basically, one class just relies on another class existing in order for that class to run. So our driver program, for example, creates an audio item object. Here in our driver program, we create 2 of them actually. So that means there's a dependency between AudioStore and audio item. Basically, AudioStore uses audio item. The AudioStore class cannot run, it can't compile without audio item existing. So there's a dependency there, okay? The AudioStore is dependent or uses the audio item class. So this is kind of the most simple relationship, and again, it happens all the time. Basically, when one class needs another class, needs that class to just exist in order to compile and run, that's called a class dependency. But then we can get into a little bit more of a linked relationship and talk about aggregation. This is the has-a relationship. So An aggregate is an object that's actually made up of other objects. So remember that our characteristics of an object are the instance data variables. So if one of those instance data variables is actually an object of another class, that represents this aggregation or composition relationship. So in a real world example, you can think about a car and a steering wheel. A car has a steering wheel. It's made up of a steering wheel plus other parts. So this has a or made up of, it describes the aggregation or composition relationship. So for example, if we look at audio item, here's our instance data variables, and remembering that string is a class, so there's a composition relationship between audio item and string. An audio item has a string as part of what defines it. So there's this aggregation relationship. It basically means that the audio item class, part of what defines it is another class, in this case, string. So this is a much more, both of these relationships mean that one class relies on another class existing, but the aggregation is a much stronger relationship because it doesn't just need that other class to exist in order to run, but that other class is actually part of what defines this class. It's part of what makes it up. So the audio item, not only will it not compile and run, but it doesn't even make sense without the other class. Okay, so this is a much stronger relationship. So we're going to write an example that will hopefully make a little more clear this idea of aggregation. We're going to write an AudioStoreAccount class. Okay, so this class is going to describe an account that someone might sign up for, like when you sign up for iTunes or Amazon Music or whatever, you create an account. And so we're going to write a class that represents that account. That account is going to be described by the name of the person, an ID, a balance. So we're going to say that this account is associated with some sort of money that you have to spend at the audio store, and then a list of audio items that have been purchased. And this is going to represent aggregation because our AudioStoreAccount class has a or is made up of a list of audio item objects as part of what describe it. Okay. All right, so let's go ahead and create this AudioStoreAccount class. So I'm going to create a new class, AudioStoreAccount. And I've said that it's made up of a name, an ID, a balance, and a list of audio items. So that's going to start with my instance data variables, a name and an account ID, a balance of how much money the account holder has to spend at the store. And then I want to have a list of audio item objects. So there's different ways I could store this. I could store a audio item array, items owned, or maybe items purchased. But because we haven't done too many examples with array lists, instead of using an actual array, I'm going to use an array list that holds audio items. So remember that array list is a class provided by the Java standard library. So I need to import that class. Okay, and we can use generics to specify that this array list can only hold audio item objects. So we're going to talk more about generics at another time, but this is a basic way of using generics to say that this type of collection, which is just an array list, can only hold this type of object, which makes sense, right? We only want to say that the things we're keeping track of are audio items. Okay, so here's our instance data variables, and you can see here already that AudioStoreAccount has an aggregate relationship with the audio item class, and actually also with the array list class and the string class, because these classes are part of what makes up or defines an AudioStoreAccount. So audio item and AudioStoreAccount have this aggregation relationship. Specifically, AudioStoreAccount is made up of an aggregate of audio items. Okay. Okay, so let's go ahead and finish this class. So we're going to write a constructor. And we're going to just take into, as parameters, the name, the ID, and the initial balance. And we're going to say that you're coming in with no items purchased. So name gets the name, account ID gets the ID, balance gets the initial balance. And then we need to instantiate our items purchased, but since we're saying that initially you won't have purchased any items, we're just going to say that items purchased gets a new array list. And then this is how the syntax works for creating these array lists. Recall we have audio item and then parentheses. So the parentheses are because this is a call to the array list constructor, basically setting up a new empty array list. But then we just put the type in there one more time. That's the use of generics there. Okay, so there's our constructor. Let's do our getters and setters. Our getters are usually the easiest. I usually write those first because they're pretty straightforward. It's just returning information. Okay, and then we can do our setters. So our setter for setting the name will take in a new string. And we probably don't need any validity checks there. You could see the argument for checking to make sure it's not an empty string, but you could do that. That would be one way to go. I'm not going to include that, but that would not be incorrect to include that. For setting the balance, we do want to make sure that you're giving us probably a positive amount. Since this is the amount of money that the person has to spend at the store, it probably makes sense that it's a positive amount, unless there's a scenario where they might owe the store money, and so it's a negative amount. But we're going to say that you're not going to be allowed to go below a zero balance in my store that I'm creating. So I'm going to make sure that the new balance is at least 0, and if it is, then I will update the balance amount, and if it's not, then I'm not going to take any action. And I'm not going to provide a way to just completely replace the list, the items purchased. So oftentimes you might decide not to include a setter for a specific variable. If you don't think it makes sense for an outside class to be able to directly modify that variable, then you just don't include a setter. And because this variable is private, there's no way for an outside class to come in and replace my list with a new list. So instead, what I can do is I can provide a method such as purchase an item, where I purchase a specific item and then I add that to the list. But I'm not going to I'm not going to provide a way for another class to just come in and completely replace the list. Now, if you were writing this class, you might decide you do think it's important for another class to be able to just replace the list, and that's okay. Different people will approach the problem differently. But in my solution, I'm going to decide not to provide that setter method. Okay. You might also consider maybe you wouldn't want to provide a setter method for balance, right? Maybe in your purchase an item method, that's where you update both the balance and the list, and you don't want to provide a way to directly set the balance. That might be, and I can see that being a good approach too. So again, there's different approaches you can take. So none of them are correct. They're just different, and whatever approach you take, you should be able to explain or justify why it makes sense to include those setters or why it doesn't make sense to include those setters. So as long as you can explain your approach, then it's a good approach. Okay, so we've got our instance data variables, our constructor, our getters and setters. Last piece we need is our toString. And I'm going to say that my toString is going to return a text representation that includes the name with the account ID in parentheses, perhaps. And then followed by the balance and maybe the number of items on their list. Now, to get the number of items purchased, I access items purchased, and this is an array list, so I invoke a method on this array list. So I have the dot operator, and the method's called size. That'll return how many items are in the list. Okay, so there is my AudioStoreAccount class. And again, this is an example of aggregation. So the audio store account has a list of audio item objects that are part of what describe it, part of what makes up that, that object, that class. So again, these are our baseline things we include in all classes, the instance data variables, constructor, getters, setters, and toString. But now we need to think about any other methods we want to add that are specific to this class. So I'm going to add that method I just described, which is purchase item. So if a person who has an account wants to come in and purchase an item, this is going to be the method they would invoke. So what information do I need to take in as parameters in order to accomplish this task? Well, I don't need to take in any information about the account, right? Because this method would be invoked on an account object. So I already know what account I'm adding the item to. So all I really need to know is what the item is. So I'm going to take in a parameter of type audio item. I'll call it the new item. And basically what I'm just going to do is I'm just going to say items purchased. And I'm going to add something to that array list. And what am I going to add? I'm going to add the new item. And then I also need to do something else. I need to update the balance, right? So I need to say, well, actually, let me back up a minute. We should probably make sure we have enough money to buy this item. So let's find out the price of the new item. And we'll use our getter method, right? So new item is an audio item. And remember, we have a getter for get price. So this will return the price of the audio item. So if my balance is greater than or equal to the price, then I can go ahead and add that item to my purchase list. And I also want to then say the balance now gets balance minus the price. And if it isn't, then maybe I just don't do anything. Or maybe I print out an error message. Or I could turn this purchase item method into a Boolean method that's going to return either true or false. And if I have enough money, I return true. And if I don't have enough money, I return false. So now there's a way for someone who invokes this method to know whether the transaction was successful or not. So let's look at an example of invoking this method in our audio store. So here, let's create an audio store account, my account. It's going to be my name. That's my account ID. Let's say I'm starting with $10 initially. Okay. So what I can do is I can now invoke any methods I want on my account object. Like, for example, I can print out my account. Let's see, I can print out my list of things that I've purchased, which would be my account.get items purchased. Okay. And then let's go ahead and let's add an item. So let's, what did I call that method? Purchase an item, rather. So let's purchase an item. Let's start off by purchasing the first song. So song 1. Purchase helps if I spell it right. And now I can just invoke this method without and ignore the return value. But because the return value is a Boolean, I can also store it somewhere. And I can say, is it successful? And then if it is, I can print out a message in my driver program. And if it's not, I can print out another message. Okay. Now I can do the same thing with, and let's see, after I purchase it, then let's print out the account again so we can see what that looks like. And then let's try to purchase my book. So now I'm going to say my account.purchase. Book 1, and I'm going to do purchase item. The same thing, I'm going to reassign successful to that Boolean that's returned from that method, and then I'm just going to reprint out again whether that purchase was successful or whether it failed. Okay, so when I run this method, here's the initial printout of my account object. Remember that my toString method prints the name, the balance, and the items purchased. That was 0. Then I invoked printing out the array list through the myAccount.getItemsPurchased, and that printed just an empty list because I didn't have anything. Then I purchased the song, and if it was successful, I printed success, which I did. Okay. And then what did I do? Then I printed out the My Account. So now the My Account, you can see that I have $8.80 left. I purchased one item. Then I tried to purchase my book, but remember the book was, how much was the book? Expensive, right? It was $59.99. So I don't have enough money left. So that purchase failed. And the one thing I forgot to do is after the purchase failed to print out my account again, so we can see that I still only have one item purchased. And let's also actually print out the array list so we can see what that looks like. So here you can see that after my purchase failed, I still have just one item. And then I've also printed out my array list. And what you'll notice in the array list is that actually the version, what is printed for each audio item is the toString method of that item. So it prints out the text representation of each item, which if we go back to the audio item class, the text representation is the title, the price, and the duration. So we'll learn why it does this and how it does this at a later time, but that's just a little preview. This is actually the concept of polymorphism happening here, but you don't have to worry about that quite yet. Okay, so here's an example of, again, just creating a new class with instance data variables, constructors, getters, setters, toString, and then a method specific to this class. This class is also an example of an aggregation relationship between AudioStoreAccount and AudioItem. And then we had some more examples of creating objects that are instances of classes and invoking methods on those objects.